Dear student, today's topic is electrical properties of solid. The solid classified into three types: conductor, semiconductor and insulator. First one, conductors, which allow to passage of electricity current. Conductivity range 10 to the power 4 to 10 to the power 7 ohm per meter. These are two types. First one, metallic conductors allow the electricity to pass through them without undergoing any chemical change. Example, copper, aluminium, silver. Metal conduct electricity solid as well as in a molten state. This is due to the movement of electron. Students, second type of conductors are electrolytic conductors, which allow the electricity to pass through them by undergoing chemical change. These conduct electricity to a good extent when they are in their molten state or in the form of aqueous solution. In these state ionic solids, ions of electrolyte become free and they conduct electricity. In ionic solid, which defects may conduct electricity to a small extent because the migration becomes possible due to the presence of vacancies or interstitial site. So student, second is insulator, the solid which do not allow the passage of electricity or electric current, ranging between 10 to the power minus 20 to 10 to the power minus 10 per ohm per meter. Example, wood, sulfur, phosphorus, rubber, etc. And third category, student, they are semiconductor, the solid whose conductivity lies between those of typical metallic conductor and insulator, means between range 10 to the power ohm per meter, means they are middle. So effect of temperature or conductivity. Temperature increases conductivity, decreases metal, but in case of semiconductor, conductivity increases. There is very little increase in the conductivity of insulator. It means in a case of conductor the temperature is not good, but in a case of semiconductor the temperature is a greater effect. They are increase the conductivity. Insulator, there are some cases. Student, the mechanism of electrical conduction. Conduction is by the movement of electrons, means valence electron available per atom. So the next topic is bond theory for explaining the behavior of metal conductor, semiconductor and insulator. A metal lattice has an extremely large number of atoms. The atomic orbital of these metals overlap to form a large number of molecular orbitals which are so close in energy to each other that they form energy band. As the number of molecular orbitals is large, the energy levels of molecular orbitals are so close together that they may be almost treated as continuous. Such a group of energy level is known as energy band and is responsible for the name band model for atoms. It depends upon the number one, the close proximity to large number of atoms, and second, the energy difference between the pure atomic orbital. So student, the first one is valence bond. Valence band, outermost filled energy band, conduction band, the next lowest lying empty band in which electrons can move, and third one is energy gap or forbidden zone, space between valence band and the conduction band, represent energies forbidden to electrons. So student, you have seen on the display the conduction band when the electrons are joined, valence band, conductor in a metal, the valence conduction band and valence band are totally attached. In a conduction band and a valence band in a semiconductor, they have some small energy gap. And an insulator, the gap is very great, so the electrons are not conduct the electricity. So student, in a case of metal, conduction band is close to valence band and therefore the electrons can easily go into the conduction band in a good conductor of electricity. Second one, insulator, energy gap between valence band and conduction band is very large, therefore the empty band are not as accessible for conduction from valence band, cannot jump into conduction band, C band. And third one condition, semiconductor, small difference in energy between the filled valence band and empty conduction band. It increases with rise in temperature because of more electron can jump to conduction. Student, keep this point in your mind. In a semiconductor case, the temperature increase the energy to electrons can jump to the and far away from the energy gap they are conduct. So student, conduction of electricity in semiconductor. First one is intrinsic conduction. Pure silicon and germanium are poor conductor because they have network or lattice of 4 strong covalent bond. When sufficient amount of energy by increasing temperature supply, covalent bond break due to thermal vibration and electron are released. The electron leave behind positive holes at the site of missing electron. When electric field is applied, free electron move to one direction, positive holes move in other direction. The intrinsic semiconductor contain equal number of current carrying holes and electron of conduction. You have seen a student silicon. So silicon has some holes. Second condition, student, extrinsic semiconduction. Intrinsic conduction is too low to be practical. Their conductivity is increased by adding an appropriate amount of suitable impurity. This process is called doping. The impurity are of two types. First one, electron rich or donor impurity. Second one, electron deficient or acceptor impurity. So first one, electron rich or donor impurity. Silicon and germanium, group 14 doped with group 15, arsenic or phosphorus, which have 5 valence electron. Arsenic and germanium atom is substituted by an atom 4 electron from covalent bond. 5th electron remains free. This extra electron, which is not needed for bonding, becomes delocalized and can serve to conduct electricity. This type of conduction is known as N-type semiconductor, where N stands for negative because electron is. You have seen doping of germanium or silicon with other group 15 element, phosphorus, antimony, bismuth. So these are from the N-type semiconductor. When an electron is free to conduct the electricity, surplus mobile electrons. Students, second one is known electron deficient or acceptor impurities. They form P-type of semiconductor. When some atoms of germanium are doped with acceptor atoms having only 3 outer shell electrons, such as indium of group 13. Indium uses 3 electrons to form 3 bonds and is unable to form 4 bonds to complete network. Therefore, some sites normally occupied create positive holes. The migration of positive hole continuous and current is carried. This is equivalent to moving an electron to opposite direction. This type of conduction is called P-type semiconduction because positive holes appear to be responsible for semiconduction. Example, doping of silicon or germanium with group 13, such as boron, aluminium or gallium. In the display, student, you have seen, means when group 14 is attached by the group 13 members, so P-type conductor is formed. When group 14 is mixed by the doping by the group 15 elements, for example phosphorus, so N-type semiconductor is formed. Student, keep this thing in your mind because in a many time board exam the question are asked. So what are the applications? Used to make electronic compounds. First, a diode is a combining of N-type and P-type semiconductor and used as a rectifier. Second one, transistor, which are PNP or NPN sandwich semiconductor, are used to detect or amplifying radio or audio signals. And third one, a solar cell is a photodiode used for converting radiant energy of light into electrical energy. So student, on display you have seen this N-type and P-type semiconductor.